Hello everyone. In this video, we are going to discuss about example 2.10 from the chapter 2 Units and Measurements of class 11 Physics. The question is, two resistors of resistances R1 equal to 100 plus or minus 3 ohm and R2 equal to 200 plus or minus 4 ohm are connected in series and in parallel. Find the equivalent resistance of the combination when they are connected in series and when they are connected in parallel. Then use for A, that is for series combination, we can use this relation R equal to R1 plus R2, and for B, that is for parallel combination, we can use this relation 1 by R dash equal to 1 by R1 plus 1 by R2, and delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square. So let us see how to solve this question. So here you see we have given R1 equal to 100 plus or minus 3 ohm. So this is actually in the form of R1 plus or minus delta R1. Similarly here we have R2 which is equal to 200 plus or minus 4 ohm. So this is actually in the form of R2 plus or minus delta R2. Okay, now let us see the equivalent resistance of series combination of these two resistors R1 and R2. So in series combination, we know that the equivalent resistance, the formula is R equal to R1 plus R2. Okay, but here we have R1 as 100 plus or minus 3 ohm and R2 as 200 plus or minus 4 ohm. So what we want to do? We just want to add the mean values, the true values. Okay, that is 100 plus 200. 100 plus 200 is 300 plus or minus. The errors are 3 here and 4 here. So when we talked about the error of a sum, we said that the error present in the final result would be the sum of the errors present in the individual measurements. That is, we want to add this 3 and 4. 3 plus 4, that is 7. So 300 plus or minus 7 ohm. This is the equivalent resistance when these two resistors R1 and R2 are connected in series. Now, we want to find out the equivalent resistance of the parallel combination of these two resistors. Okay, for that, we can use this equation 1 by R dash is equal to 1 by R1 plus 1 by R2. When we do the cross multiplication, this can be written as R1 plus R2 divided by R1, R2. Okay, 1 into R2, R2 plus 1 into R1, R1. R2 plus R1 or R1 plus R2 divided by R1, R2. So, you see, R dash is the equivalent resistance when the resistors are connected in parallel. But we know that there will be some error present in the measurement, that is plus or minus delta R dash. So we want to find out this R dash plus or minus delta R dash. To find out this R dash, we can directly use this equation. Okay, so here we have R1 plus R2 divided by R1 R2. So from this, actually 1 by R dash is equal to this. So what about R dash? Reciprocal, no? That is R1 R2 divided by R1 plus R2. Now we just want to substitute the values. R1 is 100, R2 200. So 100 into 200 divided by 100 plus 200. 100 into 200 is what? 2 into 4 zeros, no? Then divided by 300. 2 zeros cancel. 2 into 100, 200. 200 divided by 3, this would be 66.7. So R dash is equal to 66.7 ohm. So you see, we got R dash as 66.7 ohm. Now we want to know about delta R dash. Then only we will be getting the equivalent resistance of the parallel combination, that is R dash plus or minus delta R dash. We got R dash, we want to find out delta R dash. For that, we can use this formula which is given in the question. Delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square. Okay, now I am just taking this R dash square from the denominator to the right hand side of the equation. So this becomes delta R dash is equal to delta R1 by R1 square into R dash square, right, plus delta R2 by R2 square into R dash square. Okay, or this can be written as R dash square divided by R1 square into delta R1. Okay, plus R dash square divided by R2 square into delta R2. Okay, now we just want to substitute the values. So delta R dash is equal to, we got R dash as 66.7 divided by R2. What was R2? 200, no? So 200 or 100. We are taking this, no? R1 square. So R1 is 100, not 200. Okay, R1 is 100 all square into delta R1 was what? 100 plus or minus 3 ohm, no? So delta R1 was 3. Okay, then plus R1, this is R dash square, no? Not R1 square, R dash square. So R dash square, that is 66.7 divided by R2 square. What is R2? See, here this R dash square by R1 square, that is written as R dash by R1 the whole square. Okay, and this R dash square divided by R2 square can be written as R dash by R2 the whole square. That is what I am doing here. Okay, so R dash is 66.7, R2 200, no? So 200 the whole square into delta R2, that was 4. 200 plus or minus 4, no? Okay, now see, what would be the answer now? Here we have delta R dash is equal to, see, 66.7 divided by 100. That would be 0.667. Okay, whole square into 3 plus 66.7 divided by 200. The whole square is here. So you see, this can be written as 66.7 divided by 2 into 100 the whole square. Okay, I am just taking 2 square outside. So, the 2 outside. So, it becomes 4 here, no? That is, this would be like 66.7 divided by 100 the whole square into 1 by 4. Okay, 2 square is 4. That 4, this would be 4 here outside and 100 here inside. This 4 and this 4 can be cancelled. And here we have 66.7 divided by 100, which is 0.667. Okay, the whole square. Alright, now here we have 0.667 whole square. Here also we have 0.667 whole square. That can be taken outside. Into, here we have 3 and here we have nothing, that is 1. Okay, so when we do this calculation, 0.667 whole square, you would be getting it as 0.44488 like that. Okay, into 4. 3 plus 1, 4. And when you are doing this, you would be getting it as 1.779 like that. So this can be approximated to 1.8. So we are getting delta R dash, the error, as 1.8 ohm. So you see, we got R dash as 66.7 ohm and we got delta R dash as 1.8. So what would be the final result? That is the equivalent resistance of the parallel combination of these two resistors, that is R dash plus or minus delta R dash, which is equal to 66.7 plus or minus 1.8 ohm. Okay, so this is the answer. So in this video, we have discussed about this example 2.10. I hope you understood this. Thank you.